Okay, problem 11.7. Now let's consider the rank 1 update algorithm and assume that H naught is positive definite. We want to show that this must be positive. We want to show that if this is positive, then the HK plus 1 must be positive definite. Okay, so recall the rank 1 update formula, which is this. Now the question is, if this is positive definite and this denominator is a strictly positive number, then this HK plus 1 matrix must also be positive definite. And to show that, we know that we just need to multiply X transpose and X on both sides, and we want to show that this number, which is this is a scalar, right? We want to show that this is a positive number as long as X is non-zero. Okay, so since you applied X transpose and X on both sides, we need to do that for this side as well, X transpose and X. So that gives us this plus this. So since these two are the same, so when I multiply the X on the right and I have X transpose on the left, eventually the numerator just becomes the square of that thing. Okay, so the denominator is untouched. Okay, now since we know that denominator is positive, so the numerator must be greater than or equal to 0 as well. So we know that this whole thing on the right-hand side must be greater than or equal to this. And it has to be greater than or equal to 0 for any x, since hk is positive definite. Actually, if x is non-zero, we know that this must be positive. Okay, so it's like this thing is lower bounded by that, but this is positive definite. It's always greater than or equal to 0, and it's 0 equal to 0 only if the x is equal to 0. So that's why this must be also greater than or equal to 0. And if it is equal to 0, that just means that this is equal to 0, and that means x is equal to 0. So in a way, we can see that the hk plus 1 is also a positive definite matrix.